Hello, today I'm going to do a couple of quick series of videos on a repair of an HP 8642B. You can see right up there, got this guy secondhand. Wasn't too expensive, but there's a bit of a problem with it, so we're going to go take a look at that and see if we can at least isolate the problem and maybe fix it. Not sure about that. The test setup is basically really simple. There's the output here, which is going to be connected all the way up here to a scope, Venerable 2225. The output will be set for 50 megahertz, and we'll start off with a power output of 0 dB. And we'll see the waveform on the scope. Okay, so here we are with the instrument powered up, booted up. We're going to just go ahead and quickly set the frequency to 50 megahertz. Oops, sorry, 50 megahertz. And we're going to set the output amplitude to 0 dB. And of course, this is now actually generating a signal on our cable, so let's go quickly and take a look at what we have. Alright, so we have a bit of a signal here. This already doesn't look right. This looks a little bit too attenuated. Right now we're set to 5 millivolts per division, and our sweep speed is pretty darn fast. It's 0.05 microseconds, so 50 nanoseconds per division. So we're looking at roughly 2.5 millivolts peak to peak, and yeah, that's about 10 megs. So 50 megs, sorry. So where's the issue? Well, if we adjust the amplitude, so I'm going to just go switch this so that we're changing 1 dB at a time. So if we start switching this down, we should start seeing this go into place, and then boink, that doesn't look right. This is going back up, this is going back down, reducing of amplitude. First of all, we're going to go and take a quick tour, and by quick I mean let's really just go take a look at the output section and work our way backwards, just to see what is supposed to be going on, and then we'll see what we're going to do about trying to troubleshoot this guy. So first of all, we're going to start at the output here, and that actually is connected all the way back over to that SMA connector there. Now, if you look at the schematic, actually the block diagram, which is helpfully printed on the inside of the top part of the case, good on you, HP. This is a module that we're looking at here. So the output is down here, and it traces all the way back up and comes here, which is then connected into here. So the A19 module is the first major module that we run into in this on this instrument. Now this is the attenuator doubler module, which is, by the way, different between the A and the B models. The A model actually has the A16 module here instead, which is a bit different. I'm not going to get into details, but there. So this guy contains, amongst other things of interest, an attenuator and a mix-in for, I believe, some of the modulated output. But again, that's not necessarily a big deal for us right now. Let's go quickly to the schematic and see what actually is in here. So working backwards, and you'll have to pardon my screenshot here. I didn't set up any screen capture software for this. So we have the output here on the schematic, and it's going to go through a protection circuit for reverse power protection, which I don't think is the issue, but we'll take a look at that later on. And then it goes right into 2 modules right here, AT19, AT1, and AT2, which are attenuator modules. Fairly straightforward. You have the 2 SMA connections, and we have a bunch of digital control lines here. So, and then after this, we end up going into a set of switches, which I'll show you on the actual module in a second to relate this back here. So this is, I mean, we could take a look at this first, and we will test this. But this is where I suspect our problem is. This is the culprit, I think. Following from the schematic, let's start with the output, which is actually right here, and work backwards. So this is going to go right to the output of the reverse protection circuit, which I don't think the problem's there, but we'll isolate for that, and we'll test that. And the output from that is going to go, or I should say the input from that is going to come from the attenuator, first attenuator module, which again is connected in series with the second attenuator module. And of course is then going all the way back over here to one of the two RF switches. We saw these very small part of this in the schematic. I didn't touch on it just yet because I'm not entirely sure. In fact, I'm pretty sure that's not the problem or where it is. I'm pretty sure these guys are the culprits, but in any case, we'll test that. We'll test the output from here. And if it turns out that we still have the problem here, or at least something that looks like it, we're going to come all the way back through here, which is the input of the A19 module, which is connected to the output of the heterodyne module. Now this guy is only used in two certain bands, that two heterodyne bands, which I'm not going to get into because I don't know a heck of a lot about. So we're going to leave that there for the moment. I really doubt this is the problem, and if it is, we'll have to follow back afterwards. Not that there would be any trickery, but we have to verify just to make sure. So we're going to just check to make sure everything's okay, and right now I have the sensor plugged into the reference output of the power meter with the reference turned on, and that will be outputting 1 milliwatt or 0 dB, and we're pretty close. I'm not going to argue about this. This is all second-hand equipment, so this has not been calibrated in any shape or way, so getting this kind of result is okay for our purposes here, at least mine. So what we're going to do is we're going to turn that off. We're going to unplug this, and we're going to set up and reconfigure back here, and we'll run the test. Alright, here we are with our test setup. So you'll see we've set this for 0 dBm output power. We've got our setup as before. Now with our power sensor, in line with the output of the attenuator. And if everything is set up correctly, we should be seeing, ta-da, minus 0.07 dB, but close enough for our purposes. So this is pretty darn close to 0 dB. So this is telling us a couple things. First of all, that when the setting of the signal gen is set for 0 dB, at minimum, after the attenuators, you're seeing the correct setting. So now let's go and set up, or let's go change the the output power. Sorry, we'll go set this to. Actually, we'll just directly key it in. So we'll set this for 10 dBm, and we'll verify now. There you go, pretty darn close. So when we're going above 0 dBm, and in theory the attenuators aren't in, everything looks fantastic. So now let's go try minus 10 dBm. So minus 10 dBm. Now I don't know if you heard that, but the relay, or I should say the solenoid, in one of the attenuators fired. So something went in or out. One of the pads went in or out. So now what do we got here? Oh, here, this is interesting. We have 0.19.2 dB. So already something, we should be attenuating 10 dB, but we're not. There's something obviously wrong with the output. So let's try minus 20 dB now. And well, here's the second problem. We didn't hear anything happen, and technically with minus 20 dB we should have seen or heard at a minimum another attenuator pad click in, which we didn't. So let's go see what we have here, and oh, look at that, roughly the same reading, so no change. So we're now minus 20 dBm under the 0 reference that we set for ourselves that we know is working, and we clearly don't have minus 20 dB of attenuation. So let's go one step further. Let's go and try 30, which is the 10 and the 20. Well, actually, let's try minus 40, because that would be the other pad that we would be clicking in. And I didn't hear anything again, so let's go take a look. Oh geez, this is horrifying. So this is not working at all. There's something clearly wrong. And say we try 80, which should mean both 40. Oops, sorry. Let's try minus 80 dBm, which would be both 40 dB pads. Again, nothing here. Clicked in. Now, this is a plus 20 to minus 30 dBm sensor, so of course we can't measure it down to minus 80, but we should see it hit the noise floor of the sensor, which would be somewhere in the minus 35, 30 dB range, and we're not seeing anything near there. So, at this point, I'm going to start just scrolling back and forth. We're going to go up and see what we see here. We're at minus 50 dBm, minus 30 dBm, minus 20, minus 10, 0. Oh, just clicked something in. Bang, there we go, 10 dBm. So we're plus 10 dBm now. So something's clearly working at that point. Alright, I'd like to do one last check, or test I should say. So we're going to do a quick check or test before, the point right before the attenuators. And I've hooked up the power sensor here to the output of the RF switches. So we should see, of course, not minus dB, because this unit without the attenuator is not possible, negative power less than 0 dB. But we're going to do that and take a look at it. So right now I've set it for 0 dB. I'm going to turn, and of course you can see we're at minus 23, which is basically the noise floor reading. So we're going to turn on the RF pathway, and boink, we get 5 dB already. Oh, that's interesting. Okay, so let's go and scoot down a little bit. Take the amplitude, and we're going to go bring this down. And we should see this. Now it floats between what looks like, here, I'm going to scoot back up. Yeah, it looks like it's basically floating between 10 and 5 dB. What's interesting is I'm hearing the attenuators click in and out, which is, I didn't hear that before, so there might be something weird going on here, so we're going to take a look at it, I think on the bench.